Hey guys, Mr. Gran, continuing finals review. This is going to be on sequences and series, so everything you need to know about sequences and series. All right, so when it comes to finding terms of a sequence, when we're generating a certain number of terms, we could have either an explicit form or a recursive form. And the way I can tell the difference is the explicit form just kind of looks like a normal formula, except instead of y, it's a sub n, and instead of x, it's an n. And the recursive, I can tell because it tells me what the first term is, this a1, and it has this little a sub n minus 1. All right, so here is how you would use both of these formulas. Generating the first 5 terms, for the explicit form, the first term would be, we simply plug in 1, 2, 3, 4, and 5 for n. So 2 times 1 squared minus 10, that is going to be negative 8 for our first term. And then we plug in a 2, and that is going to be negative 2. Then we plug in a 3. That is 18 minus 10, which is 8. Then we plug in a 4. That is going to be 32 minus 10, which is 22. And then we plug in a 5. And that is going to be 50 minus 10, which is 40. Right? So just notice what I did there. All I did was I replaced n with 1, 2, 3, 4, 5, like that. Okay. When it comes to a recursive formula, this is probably the number one mistake that we see is students skip the first term. It always gives you the first term. So the tricky part is that first blank on the test is a negative 1 for your first term. Then for the subsequent terms, you're going to plug in the answer for a sub n minus 1. So we're going to change this to whatever the previous answer is. So our first term is negative 1. Our next term is going to be 3 times negative 1, which is negative 3. Our next term is going to be 3 times negative 3, which is negative 9. Our next term is going to be 3 times negative 9, which is negative 27. And then 3 times negative 27, which is negative 81, like that. So you just keep plugging your answer and you keep reusing your answer in recursive form. All right. Arithmetic sequences. There's 2 important types of sequences that we cover. One is arithmetic, one is geometric. Arithmetic is an adding or subtracting sequence. You add or subtract to find the next term. The number that you're adding or subtracting by is known as the common difference, and we denote that as a lowercase d. And we really have 2 terms with, or two formulas with this. We've got our explicit formula, our sequence formula, which is when we are finding a specific term. And then the sum, this is actually the series formula. When you're finding a sum, it's called a series, is the sum of a sequence. So if you add it up, instead of finding the 10th number, you add up the first 10 numbers. Okay, so one thing you'll be asked to do again is determine, is it arithmetic or is it not arithmetic? So is this an adding or subtracting pattern or not? Let's take a look at this first one. So to get from 1 to 5, I can do a plus 4. Then if I do another plus 4, I do get to 9. Another plus 4 gets me to 13, and another plus 4 gets me to 17. So that's good. D is a positive 4, and it is arithmetic. If I look at the next one, negative 1 to 3, that's a plus 4, but then now to get from 3 to 5, that's a plus 2. To get from 5 to 8 is a plus 3. So the pattern breaks down. It's not the same number each time. So this is not an arithmetic sequence. So, not applicable for there's no common difference. All right, so finding any term. This is your formula for the explicit formula for an arithmetic sequence, where a sub 1, this is your first term, n is the number of terms, and d is your common difference. So in order to do this, in order to find, we're looking for the 22nd term of this sequence, I need to know these things. I need to know what is a1. Well, that's 10, right? That's your first term. I need to know the number of terms. Well, that's given right here. That's n. And I need to know what the common difference is. Then I can plug this in. So what is the common difference to get from 10 to 21 is plus 11, and that works for the rest of them as well. So that is our common difference. Now I can plug all those things in. So this is going to be 10 plus parenthesis 22 minus 1 times the common difference, which is 11. And if I plug all that in correctly, I should get 241. All right, difference now with the series, right? We want to find the sum of the first 30 terms of this sequence. It's a different formula. So with this formula, again, I need to figure out the things that I need to plug into here, right? What are all my variables that I can plug in? I've got n for the number of terms. That goes in there twice in this formula, so we're looking for the sum of the first 30 terms, so that's n. I need to know what is a1 again, our first term, and I need to know the common difference, which in this case is a minus 9, right? I'm subtracting 9 at each step, so that's my common difference. All right, so let's plug all this stuff in. It would look like 30 over 2, and then 2 times 7 plus, in parentheses, 30 minus 1, and then times the common difference, negative 9. Now I'm going to throw another little set of parentheses around that. I like to do that anytime it's a negative number, just to make sure that things don't get goofed up in the calculator. All right, plug all of that in, and you can do as much of this as you want by hand, break it down a little bit, and then plug it into your calculator is not a bad way to go, and we get negative 3,705. All right, so our other type is geometric sequences. These are sequences that use multiplication or division to get to the next term. Now, instead of a common difference, it's a common ratio, and we use r to indicate the common ratio. And we again have two formulas, an explicit formula, which will be on the next slide, and then the sum or the series formula. All right, so determining whether or not something is geometric. Let's see can we get from one to the next by multiplying. So 2 to 6, I can do that by times 3. 6 to 18 is also times 3. 18 to 54 is also times 3. So that is going to be a yes, and r equals 3. Let's see, negative 3 to 0 is a times 0. And then things break down. I can't times 0 by anything to get to positive 3. So this one's a no. That's an arithmetic sequence. Now this last one, notice that it's changing signs. Now don't get confused by that, right? Let's think about what number I need to multiply to get from 2 to 4. I need to do a times 2, right? But then I also need to change it to a negative. Well, anytime that happens, anytime you change the sign, you're just multiplying by a negative. So times negative 2 gets to negative 4. That times negative 2 gets to a positive 8, times another negative 2, 16, and then it flips the sign to negative. So this is going to be a yes, and r equals negative 2. All right, here is our explicit formula. Again, it's actually a little bit simpler than the arithmetic one. We just have the first term, the common ratio, and the number of terms, but we're using the number of terms in the exponent. All right, so finding the explicit formula and the 10th term of those sequences. I think these were the two sequences from that previous example that were geometric. So we know that this one was a times 3. Let's see, I need to know what A1 is. A1 is 2. I need to know what R is. R was times 3. And I need to know what N is. N is 10. And so our explicit formula is 2 times 3 to the n minus 1. That's our formula. And then to actually figure it out, I would plug in 2 times 3 to the 10 minus 1. And if I plug that in correctly, I should get 39,366. I have it written down on the side here, and I might have that last 6 might not be correct. I can't quite read my writing. I was scribbling. Okay, So if you get something close to this, if the first 4 digits are right, you're probably right. Okay, with our second one, same thing. A1 is 2. We're multiplying by a negative 2. Oh boy. So that is our R. Try that again. Negative 2. That's better. And then n is still 10. So our explicit formula is 2 times negative 2 to the n minus 1. Again, I like to put the negative in parentheses. So then 2 times negative 2 to the 10 minus 1. That is going to give us negative 1,024. All right, then our series formula, same idea. It's just another formula. Now we want to know the sum of the first 10 terms. But again, I need to know just a few, basically the same information. What is the first term? That is 3. What is the common ratio? It goes in there twice this time. That is going to be 2 because this is a times 2 pattern. And then I need to know n, which is 10. All right, so let's plug all that in. A1 was 3. 1 minus 2 to the 10th over 1 minus 2. Now when you plug this into your calculator, you can't, you could use the fraction option if you know how to do that to get it to look just like this, but what it's going to look like in most of yours is going to be this. If we do 3 parenthesis 1 minus 2, raise it to the 10th power, then hit the right button to get back down so you can put a parenthesis in, then divided by to get the little fraction bar, and then do parenthesis 1 minus 2. If you don't put parentheses around the 1 minus 2, it's going to divide everything by 1, figure out what that number is, and then subtract 2, and it's going to be way off. All right, so if you do that correctly, if you plug it in just how it looks, you should get 3,069. All right, I think that is it. Yep. Hopefully you found that helpful. Let your teacher know if you have any questions, and good luck on the final.